Hey guys, welcome back to another episode of We Builds. Here onwards, बाकी के जो episodes हैं, they are going to be very interesting because we are going to use Arduino Leonardo for the remaining part of our build. So आज का जो episode है, उसमें हम बनाएंगे trim tab. So airplane can be trimmed in two directions for the pitch and for the yawing. So trim tab is basically just a control which we can rotate, stabilize our plane in both of those direction, yawing and pitching. So right now the one which we are going to create in this episode is for the pitch one. Okay, it is a small tab which is usually installed on the elevators. So we have to create a wheel and then connect it to Arduino Leonardo to give the input to our computer and make it work like a trim tab. So before moving forward, let me show you how far we have reached, what we have done so far. ये हमारा सेंटर कंसोल इतना कंप्लीट हो गया है. इसमें ये वाले जो सारे स्विचेस हैं, दे आर कनेक्टेड टू द कंट्रोलर. सो डायरेक्ट प्लस पुश बटन मैकेनिज्म. सो इसमें ये थोड़ा सा मैंने मॉडिफिकेशन किया है. इट्स अगेन अ पुश बटन, बट बस ये एक ऊपर लगाया है टू गिव इट अ फील ऑफ की और समथिंग. सो दिस इज़ फॉर द की, मास्टर स्विच, बैटरी, और ये वाले बटन्स हम किसी भी चीज़ के लिए यूज़ कर सकते हैं. सो नेक्स्ट जो चीज़ें हमें बनानी है, दैट इज़ द ट्रिम टैब, द ट्रिम व्हील फॉर एलिवेटर एंड रडर and also flaps. So what I'm going to use for that is just a second. Where is it? Okay, yes. So what I'm going to use for that is this rotary encoder. Rotary encoder is here. So ये तीन rotary encoders मैं उसके लिए यूज़ करने वाला हूँ. You can see इसमें clock, data and switch. So इसको हम दोनों साइड में रोटेट कर सकते हैं. And also you can press it to use it like a button. So elevator trim, rudder trim and flaps. So what will happen, what I plan to do is कि जब हम इसको एक साइड में रोटेट करें तो ये कोई एक कीबोर्ड बटन प्रेस करे और दूसरी साइड में दूसरा कीबोर्ड बटन प्रेस करे. सो दिस वे एलिवेटर ट्रिम तो इट इज़ लाइक ऑब्वियस, रोटेट द व्हील, जिस भी साइड आप घुमाओगे उस साइड ट्रिम हो जाएगा. एंड ये वाला जो है फॉर फ्लैप्स, अगेन द सेम कॉन्सेप्ट, बट इसमें हम पूरी रोटेशन यूज़ नहीं करेंगे. इसमें विल बी रोटेटिंग इट हाफ. सो इस तरीके से ये तीन चीज़ें इम्प्लीमेंट करनी है. एंड अगेन वी हैव दीज स्विचेस जो कि हम नॉर्मल लाइट्स वगैरह के लिए यूज़ करेंगे, जो प्लेन्स में होते ही हैं. तो लेकिन इसको इम्प्लीमेंट करने के लिए विल बी अनदर वीडियो. फॉर दिस वन विल जस्ट गो विद द रोटरी एनकोडर्स. सो फॉर डूइंग दैट वी हैव a microcontroller, Arduino Pro micro. So this is the microcontroller. Let's do it. We had to solder these pins first. So I have done it already, but the video का sequence थोड़ा आगे पीछे है, वो आगे इसके बाद दिखाते हैं. So let's start with it. मैं आपको दिखाता हूँ कि how to code Arduino Pro micro and how to make the connections for these. Everything will be there. I'll show you a circuit diagram and the code as well. So let's get to it. पहले बनाते हैं इसका वो मेन जो इंफ्रास्ट्रक्चर है. Let's do it. टाइम फॉर अपडेट. ये एक मैंने कोई किसी भी एक कंटेनर का, ये मैंने किसी भी एक कंटेनर का वो लिया है, क्या बोलते हैं, ढक्कन. एंड देन आई हैव मेड अ होल इनसाइड इट एंड ये रोटरी एनकोडर इस पे लगा दिया है. सो दिस कैन बी नाउ यूज्ड एज आवर व्हील फॉर द ट्रिम. So it can be rotated easily. Okay, अब इसको अपने console में fix करना है. That is the next step. Let's do it. Guys, there you go. Our trim tab is complete. Let's give it a test run. Feels natural. Let's see. Cool. Yeah, I also need to show you the connections that I have made for this. Let me just show you. So here is the Arduino board that we are using. So isme we have used 4 connections, not actually 4, only 2 input points, and one is plus voltage and another one is ground. So that way 4 wires are connected to our rotary encoder here. So ये जो 4 तारे हैं 1 2 3 and 4, these 4 wires are going to this rotary encoder inside. Okay, and when you rotate this trim tab, it is basically just rotating that rotary encoder. और ये जो है we have because of the spacing issue, यहाँ पे इसको एक छोटा सा wooden piece लगा के उसके ऊपर I have just pasted this using a glue gun. So ये सब करने के बाद it is quite stable. And ये वाला part हमें काटना पड़ा, so that because the wheel was too big for this box file, so when we just close it like this, it pops out. So you can just simply rotate it up and down for whatever trim you want. Yeah, and also you might ask, what is this for? This is to support the wheel so that it doesn't pop out this way. So when I close this, if you can see, that actually supports the left side of the wheel for rotation, and it is smooth enough, so there's not much friction. It just gives a realistic feel. Yes, so ये जो 4 तारे हैं, इनमें से 2 तारे I guess not these 2, but these 2 wires are simply connected to positive voltage and ground, and these 2 are, one is clock and other one is data. So these 2 wires actually tell the rotary encoder which tell the board which direction the rotary encoder is being rotated. So ये सारा connection है इसके लिए. Let me show you the coding part also. ये जो अपना the Leonardo board that I have fixed inside the console, and this is the USB cable that is connected, and this is another USB cable to extend it. So this goes outside, and then we can connect this to our system. So अभी जो इसकी coding भी करनी होती है, we have to program this Leonardo board. So that is also done through this USB cable, and other way around, when we connect it, we can just use it to manipulate the trim. So this trim tab is complete. Let me show you the coding part.
So guys, we are in the theory class. This might sound a little bit boring to you, but this but trust me, it is going to be very informative. So just hang on for some time. So let me show you the circuit and how we connect this rotary encoder to our this Arduino Pro Micro. So this Arduino Pro Micro is actually based on Arduino Leonardo. So one and the same thing. The only difference is that it has this USB connector inbuilt. So you do not need those complex circuits to connect it to the system. So yeah, here if we look at this, where is the mouse? Okay, found it. Yeah. So if we look at the pins of this rotary encoder, we have this ground, we have positive, we have data and clock, and also we have this switch. So we are not going to use this switch pin because we have a lot of other push buttons and toggle switches which are more than sufficient for all the controls that we need. So here we just need the rotary function of this encoder, so we'll just simply use the clock data positive and ground. When we switch to the microcontroller, so this is ground, so it has multiple grounds. You can use any one of these. So we have 1, 2 and 3 grounds, and this is the VCC that we are going to use. Okay, this is about the ground and VCC. This is about the power. Then about the data, we have multiple input and output pins on this board. So these are all input and output pins. You can configure as you want in this. So there are some analog pins like which is 1, 2, 3, 4 and like this. So these are the analog pins, but since this is a digital encoder, in the name itself it says we need digital pins for that. The thing is, we can use this analog pins as digital as well as analog inputs, and the remaining of the pins are digital pins already. So you can use any of these pins to connect the rotary encoder. So let's start with the power. I'll connect this positive to VCC. There goes to VCC. Yeah, the first connection is made. Now let's connect our ground. Let's connect our ground to one of the grounds. So since we are going to the right side, let me just connect it to ground on the right side itself. Okay, there you go. So now, okay, there is a connection if you scroll down, so don't think that it is disconnected. So yeah, the power connections are made. Next is I need to connect the data pins. So I'll be using this 2 and 3 to connect the clock and data. Doesn't matter, as I told you, you can use any of the pins that you like. So I'll just simply connect it to 2 and connect it to 3. So this is basically all the circuit that you need to make for the board and the rotary encoder. Yes, and then you simply connect a USB cable here and connect it to a system, and then you can program it. So this is the circuit diagram. I hope you understand this. So let's move on to the programming part. And now guys, the next thing that you need to do is to download the programming software for Arduino. Arduino programming. Let me show you how you can find it. Yeah, this is actually the software that we are looking for. It looks like this, but yeah, where's the link? Or I'll go for download Arduino IDE. Yes, sounds correct. Yeah, software Arduino. Okay, so here is the software. It's absolutely free. You can download it from here, Windows zip file, and or whatever is the operating system that you are using. I am using Windows, so I have downloaded this one already and I have installed it on my system. So I'll just simply open it. Yeah, and by the way, that's my house. I just took this picture before the renovation, so it has completely changed, but yeah, that's the old look. So yeah, going to the Arduino IDE. This is the IDE and this is how it looks like. I'll go to file, click on new, close this one. So when you open it, this is how it will look like. You'll have this setup and loop. So what happens is, as soon as you plug in your Arduino, the first the void setup, this function is executed, and this is executed only one time, and then after that it keeps on looping. It keeps on repeating the code whatever you write inside this. So let's start with the coding, and I'll keep explaining side by side as we go on. Okay. So even before the setup, first we'll include the keyboard libraries, because I plan to use the keyboard buttons to perform all the functions for the simulator. So it's like this. You can just simply copy this. It's keyboard.h. Then I will need to define then I'll simply define the pins, that is 2 and 3. Oh, I'm sorry, yeah, it will be like define CLK. You can put any name. I'll just name it as 2 and the pin number is 3. And again define data. The data pin I'll define as data and name it as 3. Okay, now I will use two more variables. One will be the current state of clock and other one will be the, okay, you need to end this with a semicolon. Other will be the int previous state of the clock. Okay. You can name these variables as you want. It's not necessary to name the same, but yeah, I am using these so that I can identify the variables properly. Okay, now our variable definition is completed. I'll remove this line and move on to setup. So we need to define the pin mode, whether the pin is some input pin or output pin. So I'll just make it pin mode of clock as input. Okay, this is done. And also just copy paste this because the data pin also is input pin. We do not need any output pins as of now. So all the pins that we are going to use are going to be input pins. Okay, now data pin is also done. Moving on, this is something you need to do, that pin mode. No, sorry, yeah. So here this line you just I'm also not that experienced in coding this, but yeah, this line has something to do with the clock cycle or something, so you just copy paste it as such, and we'll read the value for the previous clock now in the setup. So we'll just say previous state clock is equal to digital read and CLK. So what it is doing is it is reading the voltage on the clock pin, that is the pin number 2. So and it is storing it as previous state of the clock, so it can be either high or low. Previous state. Okay, make sure the variable names are the same everywhere. Next we will go to the loop, and I will remove this line as well. Let's start writing with the loop. So here we need to write keyboard.begin. So for starting for starting the keyboard library. Now I'll say current state of clock. I'll just copy this. Current state of clock. Current state of clock is equal to, again, digital read clock. So what happens is it stores the previous state, and then as soon as it is looping, it again reads the value at the clock pin. So that will be our current state. Let me just close my WhatsApp, making a lot of noise. Yeah. Next we need to write a condition, that is if our current state of clock is not equal to previous state of clock, which is this one, yeah, is not equal to previous state of clock, that means our rotary encoder has been rotated already. So if the current state is not equal to previous state, then we have to take action. That means if okay, let me explain. If the current state of our clock is not equal to the previous state of the clock pin, that means that the rotary encoder has been rotated in either direction. That doesn't matter which direction, but it knows that it has been rotated, so it is the time to take some action. So if the current state is equal to previous state, that means the clock the rotary encoder has not been rotated in any direction, so you do not have to do anything, just keep on looping again. So when you know that the clock that the encoder has already been rotated, then you need to find out which direction it has been rotated. So we'll put another if condition, and in the if condition we'll write digital read. I better just copy this. Yeah, digital read, but this time not at clock. This time we need to read at data. Digital read at data is not equal to current state of clock, this variable. Then I will press any button that you like. So let me just press T. Okay. Else I'll just copy this again, and I'll press some other button. So I'll just, let's say, instead of T I press Y. So what is happening is this line finds out if it is rotated clockwise or anti-clockwise. So let's say it finds out that it is rotated clockwise, so it will press T, and if this condition is not satisfied, that means the pin is rotated in the other direction, and then we press some other key. Okay, next what I'll do is this action is really quick, so doesn't matter which direction it is rotated. I'll just give it a delay. So I'm sorry, a delay of whatever you like. I'll say 500 milliseconds. So let me explain why I'm doing this. For the trim tab, when we rotate it, it is too quick, and the explains the flight simulator is not able to recognize the the key press as a trim action. For other actions, like for pressing some button or something, it absolutely works fine without the delay. But for trim specially, you need to press and hold the button for a minute amount of time for it to work. So that's why I'm giving a delay of 500 milliseconds. This is in milliseconds. And then I'll press I'll just then release the keys. Keyboard dot release all. Yeah, whatever 3 keys you have pressed, just release all. So this is all the program that you need to write. If you understand it, good. If you do not understand it, do not worry, just copy paste this and it should work absolutely fine. So let me just try to compile it and see if it is working or not. Oh, I need to save it first. I'll go to desktop, and I have a folder flight simulator. Where is it? Flight simulator. I'll save it here as demo. So this file is being saved, and now it is compiling the sketch also, as you can see here. Let's see if we have any errors or something. If in case we get some errors, we'll just fix them. Yeah, so we have one error, and it says initializer before setup. Expected initializer before setup. What does that mean? Okay, looks like we forgot to add this semicolon. Let's try this now. Okay, so the compiling is successful. Now let me show you some settings. If you go to tools, um, I don't know, yeah, if you go to tools and if you select board, so this is the place where you have to select what kind of board you are using. So we are using an Arduino Leonardo. This is what you have to select, and then this is the button, upload button, that you just connect your Arduino board through any USB port and then click on this button and it should upload the code. It's pretty easy, nothing to worry about, and as soon as you upload it, you can just use your device as a flight simulator. So yeah, this part is done. This is how you code a rotary encoder. Okay, so what it is doing is, if you rotate it in one direction, it is going to press the key T for 500 milliseconds, and in the other anti-clockwise direction it is going to press the Y key for again 500 milliseconds, and it will again keep on looping this, looping as in it will keep on repeating these steps, these if else conditions, and the number of time you rotate it, it will give a T or Y input to your flight simulator. Now all you need to do is, in your flight simulator, you need to assign T and Y to the trim controls, and that's all. So let me burn this to my Arduino and then we'll see if it works or not. So we are at the Chandigarh International Airport and we need to test if our trim tab is working or not. So let's go to the inside view. This is the cockpit, and here this is the trim wheel, which is supposed to rotate when we are rotating our trim wheel here. So let's see if it works. Oh, if you can see, the trim wheels rotate up or down when we rotate it. See, this is down and this is up. Great, it works fine. So this is how you install a trim wheel in your flight simulator. Yeah, though I realized that I've been calling this a trim tab throughout the video, but it is actually a trim wheel. So yeah, we are done with the programming. I've shown you it works absolutely fine. It feels good. So the trim tab is complete. In the next video, we are going to work on our flaps, landing gear, and if possible we'll work on the rudder trim control as well. So yeah, that's it. Also I'll share the code, if in case you don't want to type that big code. I'll just share it in the description. Do check it out, and in case you have any doubts or anything, feel free to write down it in the comments and I'll make sure I clear your doubts in case you are stuck somewhere. Also, if you like this video, please do not forget to share, comment and subscribe. Thank you. Have a good day. Peace.
If you like this video, please consider subscribing.